Direct address tables are a very efficient way of looking up data. So let's suppose we have a database of students, and we want to look up a student by his or her student ID. So we could store that list of students as a linked list. So if we want to do it as a linked list, then suppose we have some student named Joe, and his student ID is 385, and then that can point to the next node, and this is, say, Jill, and her student ID is 741, and so on. Now, to find a particular student by their student ID, it's a linear search. We have to search through potentially the whole linked list and compare each student ID to the one we're looking for. So it's order n. But there's a better way, and that might be a direct address table. And this is an array. So here we have a table of structures, and 0, 1, these are the indices into the table. And suppose here at index 385 we put Joe. We'll go a little further. At index 741 we have Jill. And then we can directly access the record for Joe and Jill and any other student, and then get whatever other information we need, GPA or whatever. So this is a direct lookup, which means that the array at index 385 gets the Joe record. And this is a constant time lookup. So it's super efficient. Now, what if the smart people here at Idaho State decide, well, we want to look to the future. We want students to be able to keep their student ID for the rest of their lives, and we're going to grow, and we're going to have lots of students, and we want this student ID to last a long time. So, what if the student ID was in the range of 0 to 1 billion? Now, this is not unusual, right? You have driver's license numbers, you have social security numbers, and these are all, the biggest number you could have is massive, and but it's sparsely populated. But that's, there are various reasons for doing that. Well, suppose we did that. Okay, so a student ID is between 0 and a billion. Suppose, furthermore, we have 15,000 students initially in the system. Then the array size is 1 billion. That's a big array. And we have maybe 15K entries. So most of the array is empty. And that's a waste of space. Can we use that space more efficiently? The answer is yes, we can use hash tables.